Welcome to another episode of TIS-100. This is part 10. The simple sandbox is just the user segment, so I won't be doing that because it's just creativity. So I'll be doing the signal pattern detector. So we read a value from in, we look for a pattern. 0, 0, 0. Okay, so I guess this is the pattern. Write 1 when the pattern is found. If not true, write 0 instead. Fair enough. So what I can do is I can take an input. Okay, so the pattern isn't found. Not found, not found. No, 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 no. Yes. Oh, and that's true. So yes, yes. Apologies. I'll go back. So what I was doing was, yeah, so the pattern was found, 0, 0, 0, 0, 0. Now it broke, which means it broke. Okay. So we have to somehow utilize the 2 registers per node in a way where we can save the previous registers. They can input. So whenever, let's say, I take an input, and if it's a number, then I will reset some of the counters. And therefore, I need a counter that says if it's true or more. And I want to reset the counter after 3, just not increment it. Okay, so I guess I can give the counter to this little box, or maybe I put in here because I want to go here quickly. Yeah, but then I have to go back. So here, left, down. I'll go right. Just so I have more potential later to increase these boxes. Nodes, not boxes, nodes. Okay. Move up the accumulator. Okay. Then I'll say now I'll actually move up right. I'll add from the left. What I'll do is add from the left, swap, and I'll move, and I'll move up, ac. I'll move ac right, move ac right. Add left, then I swap. No, I don't. I'll add it once. Add it once. I'll say move left accumulator. If the accumulator is equal to 0, do something. So what will it do? It'll increment the counter. So it'll do a swap. Increment the counter by 1, and then swap back. Swap back, and I will I'll increment the counter by 1. I'll check J. So what I'll do is I'll use one of my other strategies, which was, so my counter isn't back. So I have ac, which has some value, x. Then I have back, which has some value, y. If what we want to do is we want to say, is y greater than or equal to 3? But of course, we can do an algebraic manipulation and say, is y minus 3 greater than or equal to 0? So that's what we can do. So what I'm going to do is I'm going to add 1. I'm going to save it to the registers, so they're both the same. Then I'm going to say sub 3. Then I'm going to say j greater than 0. J is greater than equal to 0, greater or equal to. So we should actually instead do y minus 3 is, we want to check the opposite condition in assembly. And then jump somewhere if that's the case. J just less than 0. I'll just say less than 0. And which means less than 0, it's bad, which means we'll just send move 0 down. And then if we're only gonna send it once, I'll just move it right instantly. So I'll accept the input if it's 0. Then I jump to easy, else I will jump to LZ. And not increment. I guess I can, because there is an edge case here where I have a bunch of zeros forever, and it reaches the 32-bit limit of, I'm assuming this is 32 bits, and then it overflows back to 0, which will cause an error, which means I have to make sure I don't cause that error. So I will reset. I'll say, ooh, wait. Swap save. Jump L. I'll swap. I'll add 1. I'll save it. I'll say subtracted by 3 is less than 0. If it is 0, else I will move 1 down, and then so instead of swapping back, I'll move 1 down, I'll swap back, and I'll say move accumulator 3, just so it doesn't overflow. Move 3 to the accumulator. Cool. Down. Okay, so I read in the value 2. Okay. I read in the value 0. I'll add 1 to the thing, I'll save it, subtract it by 3, it's less than 0, so I'll move down. And this is the second 0, which means I added 1, save it. This is broken. Oh, this is broken. If it broke, the chain has to get reset. Oh, the condition must be different here. It's very close, I think. But it should be very much wrong. Yeah. So, so which condition can I separate? So I'll bring it here because I think it is actually a bit easier to deal with. Down. And I can separate it a bit more. Let's say move left accumulator. If it's a 0, straight away, then you want to do this stuff. Sorry, you want to do this stuff. No, if it's not a 0 straight away, then you want to reset the counter. So what I'm gonna do is I'm actually gonna have this easy check. Yeah, easy check. And jump LZ. Easy check. In here. Right, LZ, and I'll say this shouldn't be here, and I'll say LZ is move 0 down, move right. So the easy check, we remove. Easy, wait, that's an error. I think it's an easy check in here, which means we'll move ACK left, move left ACK. No, but it's not ACK, we'll say swap, move left ACK, and swap again. And then jump to L. Jump to LZ will say swap. So there's something in, not really, swap, then I say move 0 ACK, swap back. Okay. And it's not left. Left accumulator, move up accumulator. Like so. LZ, where's the LZ check? If it's less than 0, we will still we still have to send something to the right, because that's what it's expecting. So I'll say it's gonna be 2 instructions. Wait a minute, right? Down. No, right. Uh-oh, it's not expecting anything. It should be expecting something. No. Right, accumulator. Well, let's see. Takes 2. 2 is not equal to 0, which means it won't do that. It'll just jump all the way here. It'll move 0 down, and it'll swap it. It'll reset the thing, and it'll swap back. Okay. So the first answer is correct. Now the second answer is 0 as well. But that means now we send the information here. We add to the accumulator, we save it, we take away 3. If it's less than 0, we'll move down 0, and then our accumulator is, what is it, 0? Swap. Blah, blah, blah. And 1 so far. Now it's still 0, but ooh, uh-oh, what happened here? Okay. This back should be reset. The back should be reset. X60, X86 and X64 is messing me up. There you go. Wait, that's another 0 in an increment? That's confusing. Ba, 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 ba. 1. No, you don't want to swap it. Two zeros. So wait a minute. Oof. Yeah, no, that's not good. Yeah, that's not good. It does that. It does that again. Then it fails the easy check because it's a 3, so we must reset this one. Which we don't. Big issue. Big issue. Yeah. One forever. Wait. A deadlock. Up, down. So it's stalling most of the time. What I could be doing is having this same checks in here. Just putting into here. Or actually moving this here, moving that here. This and that. Yeah. But for the moment they won't. It's good to find the solution first. And then optimizing. Okay, so... No, we can't do that. We can't do that. If we jump, we have to reset the accumulator back. Which means you have to check. Do some checks here. Wait, let me just see. Am I underutilizing? I am. Clearly. So the best case scenario is at 0. Which means it does this. So how about I have the best case scenario here. This is easy. Easy jumps. Wait, NZ exists? Yeah, not 0. Not 0. Well, I'm assuming no negative numbers, right? Jump NZ. Jump easy. We don't jump at all. Alright, move up accumulator. If it's not 0, do that stuff. Can I receive the accumulator and actually just... Wait, it doesn't even actually care about the accumulator. I could improve this by saying you swap first, and instead of adding 1, I say add right. There, and that means I will, instead of ack left, I'll say ack move ack left. I'll say move 1 left. Okay. Move a left. I add it. I save it. I swap it back. Swap it back. Wow, why are you doing a swap at all? Oh. Yeah. But we don't care about it too much though, because it's not like that accumulator it will be updated. So I move it left. I'll do some stuff. Subtract by 3, fine. Less than 0, it'll move it down. Okay, let me think. Yeah, LZ, jump LZ. Move 0 down. LZ less than 0. Which means it's not the count yet. We don't decrement anything. Move 0 to the accumulator. Oh no, we do reset the accumulator. Oh no, we only reset the accumulator because we did this operation. And move the answer so far to the right. So we will receive it from the right. Here. Yeah, but then if this condition happens, we want to swap. We don't care about the accumulator. We really don't. We only care about it in here. Yeah. So I'll move 0 down, but what I'm gonna do is I'm gonna ask I'm gonna have to send information. I'll send information. By default, I'll actually send 1. But I will receive information. And if it's, I'll take it away. I'll say, so let's say I have 10 consecutive zeros. So that's 10 consecutive zeros. And what I'm going to do is I'm going to say, I want to take those 10 consecutive zeros away. So I'll say, I want to negate the accumulator, and I'll say, move the accumulator right. Just nullifying all of that left. Move the answer down. Move the right, any right. Yeah. Okay. Let's see. We gave 1, so now it's 1. So we save it. We subtract by 3. 0 down. We reset it and we move it right. Yeah. Care, we negate it. Move it down. Uh-oh. Deadlock. We will have to accept whatever input is and we just put it to trash. Move left, nil, because we don't care at that point. Blah, blah, blah. Yeah, give me 0, nil, trash. And then we say, so this is also trash. Wait, move left. If it's not 0, move left. I would assume we'd move the accumulator down, because that's the answer so far. But it's not the answer so far. We move left. We'll say if it is 1. Let me run through the program again. We received the input. Whatever. So this is 3 consecutive zeros. Okay, whatever. It's gonna deadlock, yeah. I assume we want to go here. And also we want what do we want? We get this input thing, which should be the amount of consecutive zeros we had so far. So I guess we don't care, because at that point, if it's not a 0, we take it from the accumulator. And if we accept it, let's see, subtraction, let's see. accumulator. We move 1 down. We move 1 left. Which means that's not 0. Move 1 down. We do that here. So the answer, we don't care. Is that the thing? We don't care about the accumulator. We don't give it back. How? No, but it's necessary to give back. So I guess this can be nil. It's absolute trash. I'm feeling like it's getting closer. Just a couple of more stuff that I have to iron out. Dun 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 dun. I mean, that's not too... Is my output too fast? Okay, we get 2. We move 1. Whoa. We move 1. I don't like the sound of that. Because it's not a truly 1. Ah, I ruined it. I think it's better to send it separately. It should deadlock here. It shouldn't. Yeah. The answer is 2, which means we have to, I guess, move 0 left. -3. It's gonna give me that, and I say negate, and I want you to reset that, which it does. Move it down. Okay. Now, this is the first 0, which means you want to increment it. But it's not greater than 3, which means the answer is clearly 0. We reset that, and the accumulator, we send 0. If we reset the accumulator, it's best to just say 0. Okay, so best to just give it 0, because wait, hold up, what? I will always give 0 here, but that's not what we want. We want to swap and give the accumulator. there a label here that I can optimize out? Oh no. Well, this is a swap. So it will swap. Maybe. Okay. Our first is, well, actually not our first 0, but A0. 3. So first 1. We just throw that in the trash. I don't see it incrementing. Blah, 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 blah. After restart. I don't see it incrementing. So when it goes into here, it increments by 1. Perfect. And it should remember to keep it at 1. Okay, it's swapped. It's swapped, that's the issue. I want to swap back. I want to swap back. I can do this here, I guess. Where is it? Jump L, that's that part. Oh no, I can't. It's not that easy. Just one more swap is what I need. Invalid register. No, no, no. Why don't you swap? No. Okay, what I'm gonna do is actually not care about the edge case of the 32-bit limit. Okay. Does whatever. No, it's incrementing. It's not less than 0. Sorry. Okay. gonna send 0. Sends it to the right. And it just goes to the trash. It goes to the trash. This, however, won't quite yet go to the trash because I'll negate it. Yeah, I'll reset it. Oh no. Okay. Okay, it reads that 0. It's apparently 1. What? Clearly. No, that's too quick. That's too quick. Instead of that, what I can actually do, that goes to the most of the time it will be trash. Will it be? Was I doing useless stuff? No, it won't be trash. Okay, blah blah blah. Increment, increment. One more increment. No, it resets. So it's still 0. But it didn't reset. Okay, there you go. It did reset. And then this should be a 1. Less than 0. Else, no, it's only 1. Has to be 3. So I have to do sub, blah blah blah. I can do it here. Oof, no I can't. No, the This is so annoying. I want to just subtract this by 3. That's all I need. And swap. Well, no, just subtract by 3. Wait a minute. Put the tags in. There you go. Sub. No, sub. Move one down. Move. What is it? Accumulator left. Sub 3. I'm gonna say JLZ. J less than 0. Less than 0. Else. Move one down. That could be enough space, actually. That could be enough space. Resets the thing. That's the first 0. So that's what's going to be sent. We take away 3. If that's less than 0, we just jump. We don't send anything down. Really? No, it should be. Okay. I think I messed up, but we'll see. That resets. Now this should be 4. I'm taking in 4 this time. Clearly it should not give 1. This should give 0. Now this should give. Yeah. Yeah. I just realized after, what was it, 10 episodes that the game has actual volume, for example. And it wasn't being played. So I'll actually keep the desktop audio. Okay, let me think. Give me a second. Okay. It's annoying for sure. I want to create a new tag called I'll call it something S, or like LZZ, so I can actually use it like this. I forgot about that. Okay, LZZ 0. Boom. Why? Is it because I'm sending things down myself? I'll just think in silence for a second. This looks more promising, to be fair. 2 to 2. That looks promising. Uh-oh. Uh-oh. Ba-ba-da-ba-da-ba-da. That looked very promising, unfortunately, but it didn't work out. How did that happen? No, I get the accumulator. That should be our good answer. Okay. 2. Somehow that resets. 2. Oh yeah, 3 resets for sure, for sure. Okay. And I don't get the answer I wanted. All this time I've been getting it here. So once it actually goes here, it's all messed up. I guess 2 swaps can maybe fix it. Okay. Yeah, probably did. Oh no. Deadlock. Bum bum bum. What if I introduce this? Will it actually just make everything like magic? No. Why those? Why those though? So wait, we're getting ones. So it must mean these might. This must. These must. This must be the ones. 6. That's impossible. Oh no, mine. No, that's possible for me. A 1. How in the world did you? I think that's a 1. Probably because of this. Yeah. Wow, that was the worst program I've ever written. But it works. Wow, it's so bad. It just keeps getting worse. But hey, it works. Now I just need to optimize it, which is it clearly needs some optimization. But is there anything that's obvious that I can optimize? For example, you know, so many swaps are happening here. And it's doing the same thing. So maybe I'll just jump to the swap. My swap. And I'll say my swap. And I'll say swap. Move a key. Blah, blah. And I'll say jump L. Yeah. So what I'm gonna do is jump L, blah blah blah. And I can just jump to my swap. And I won't need to do jump L because it'll do that. Yeah. That just saves a couple of instructions, makes it neater. But that doesn't make it any better. Because we're still gonna do a lot of cycles. Jump L. Okay. Right. This is a garbage mess that I barely managed to fit in here. Holy crap. Unreadable, to be honest. Oh, sorry. Unreadable. It's awful. Like, it's so bad, I don't even want to look at it. Because it's, how did I manage to do this? How fast is it when it's running? I mean, not terrible. It has a bit of optimization where it's, wait a minute. There you go, one less instruction. Yeah. I mean, should it be this bad? Should it be 764 cycles? No, I mean, what's obvious about this? LZ, LZ, LZZ, LZZZ. I forced myself to be restrained into this node. And this code here, it is not really nice with concurrency. If I get any chunk here, it'll just cry. Yeah, it won't have a nice time. Yeah, I'll just keep it as this. I'll keep it like that. Thanks for watching.